Welcome back to the AI talk show, guys. We're super excited to have you here today. And we are also joined by Supreet. Supreet, welcome to the show once again.
Thank you, Amit. Happy to
Always
be
a pleasure having you on the show.
Thank you.
Yeah. Supreet, quick question. Where are the flying cars?
Interesting. I don't see them either, and I think I have the same question as yours. It's
Okay.
something that we've been promised since decades. Just the idea of not being bounded by any buildings or blocks and just going from one place to another seemed like a very tempting idea, but we still don't have it realized yet.
Makes sense. But I think it's been every year, there'll be like every 5 years, there's going to be a flying car,
Of
right?
course.
So finally, but today there's some exciting new development. Finally, like we are, and tonight what we're going to announce, we are going to have something, that India has wanted for decades. Like not sure about other countries, but India is finally taking a leapfrog in this, and finally I have some good news. We are going to get that pretty soon as we speak, and the work has already begun.
Right.
Yeah, this time I think I can say it confidently because we have the tech, we have the infrastructure, we have the things, we have people, we have
the
like
talent, of course.
Yeah, talent, infrastructure, everything is in place, and finally here's the real story. The flying cars are real, guys, or flying taxi, I would say.
Flying taxis, yes.
Is that right? Yeah.
Yep.
So, I will not take much of a time. So to talk more about this shift and what it means for the future of mobility, we have Vishnu Ramakrishnan, who is the Senior Vice President of Advanced Air Mobility Strategy at the ePlane company, joining us. Welcome, Vishnu.
Thank you so much for that intro, Amit, right? Thank you so much for having me on the show. A big fan of what you guys do at AIM. Happy to be sort of joining you this evening.
Amazing, amazing. I mean, Vishnu, like amazing new development. You have been one of the pioneers in terms of leading ePlane strategic partnership with NVIDIA, bringing together AI, simulation, and safety critical aerospace systems. This is a big announcement and a breakthrough that you guys have come up like just recently. Can you tell us like how should one make sense of this before we start diving deep in this conversation?
Got it. I'll probably take a few seconds to set context on what we're building and then sort of associate what we're doing with NVIDIA and how we're sort of accelerating some of that design process itself, right?
Got it.
So we are essentially building a 3-seater aircraft, right? And this 3-seater is pilot plus 2 paid passengers. That's the configuration that we're going after. Fundamentally, because urban mobility, the average number of riders per trip is not more than 1.4 statistically, right? Most Uber trips, you have not more than just one person taking it a majority of the time. So that's the market that we're building towards. At ePlane, we've been at this since 2019. It was set up by Professor Satya Chakravarti of IIT Madras. So in the past, we've built a lot of subscale aircrafts, and I think that's what you're putting up on screen as well. So what we build is called a lift and cruise architecture. Okay. So we take off like a helicopter, and we transition into a fixed wing in forward flight. And we have a different set of the rotors taking you up, and a different set of propellers that's propelling you forward. That's essentially what we're looking to build. 2019, we put together a small bird, which has a wingspan of about 2 meters. Which proved to ourselves that we're capable of A, designing an aircraft, B, putting it together with composites. This is a fully composite aircraft. And C, that we were able to write the control law to do transition. When I mean do transition, when you shift from going vertically up to now start accelerating forward horizontally, there is a transition. That is the trickiest part of this entire game, right? We want to prove to ourselves that we are able to develop the control law to do that, which is what we established with the small aircraft of a 2-meter wingspan. Post that, we actually did a lot of test flights, right? We got hundreds of hours of data on that small platform. Subsystem teams back at the office then started analyzing them, validating a lot of our design assumptions, right? Because when we started off doing the CFD or the aerodynamics itself, we were started with certain assumptions. We were now able to validate a lot of what we were assuming. Subsequently, in 2023, we could put together a subscale aircraft, which has a wingspan of about 3 meters, right? And we then flew that. Then again, a lot of test data pulled out. Subsystem teams again got to validate a lot of their assumptions, which sort of de-risked a lot of technologies going into the manned aircraft in itself, Amit. Aerospace is a very regulated space, right? And we take safety very, very seriously, right? Which means for us to be able to commercially operate, we need to ensure that we are proving reliability to the highest standards. India today has a framework for certification, right? They announced something in 2024, prior to which only FAA and EASA had frameworks out there. So we, sort of evaluated both of them, and then we sort of benchmarked, what are the standards that we need to build towards. That's what sort of allowed us to choose what design references to go after. Now, like I told you, right, in this entire effort, simulations became super critical, and it also sort of directly impacted how much of an outlay in terms of a capital perspective you need to spend towards the program, right? We've actually not raised more than $20 million till date, right? And we've been extremely capital efficient, fundamentally because we've spent a lot of time doing those simulations and fine tuning them, which means we're spending lesser money in the real world trying to sort of break things, right? We spend a lot of time trying to refine our simulation so that your cost of development is very, very efficient.
Got it.
In the process of doing that, we've now started leveraging two things that we're doing with NVIDIA. One is NVIDIA has a product line called Omniverse. There's something called Isaac Sim there. We're leveraging Isaac. So Isaac Sim is a physics simulation engine, right? So we're actually setting up our aircraft models on the tool. We then sort of introduce physics, which means we know what kind of motors, what kind of masses, what kind of torques go in. We then simulate, what kind of controllers are on board. We then try and tune the aircraft in this virtual environment, because see, as you can see on your screen, it has 6 vertical rotors that are allowing you to vertically go up. Directional control at the VTOL face is happening through, basically these rotors reducing their speed really, really quickly. That is how you're going left or right.
Correct.
We need to tune these PID values, right? And we are now looking to leverage pipelines that we've built on Omniverse to doing this. That's fundamentally what we're doing with Omniverse. Additionally, when the entire aircraft is built, we have a series of radars, cameras, and lidars that are on the airframe. All of this is bringing in data for situational awareness of the pilot, right?
Got it.
Because the pilot will be operating in urban environments, we need to ensure that he has no blind spots around the aircraft.
Got it.
To do that, we're actually building a fusion pipeline on the aircraft, and for which we are now sort of leveraging the IGX series, or safety critical hardware that NVIDIA puts out on the airframe. So we do something that's called localized compute. So there are sort of these IGX devices that are on the aircraft that are doing these computations for the pilot systems. That is what we are getting towards. So two things. One is we're using Omniverse to build those data pipelines, to validate a lot of our design choices in terms of the control architecture. Second, we're also using Omniverse to place these sensors even. So these sensors need to be placed, right? And your sensor fusion pipeline is very dependent on what the field of view of these sensors are, because you end up doing a pixel to pixel matching at the end of the day. So as opposed to you physically putting the sensors on the aircraft and then deriving if the fusion pipeline works or not, we're actually simulating for this, leveraging a lot of synthetic data that we're able to generate from the environments that Omniverse is able to give you. So that's sort of accelerating some part of your design choices at the design level in itself. That's fundamentally what we're doing with the NVIDIA.
Got it. Vishnu, just I'll take a moment to tell our viewers, like in terms of simplifying what you just said. I mean, that was very insightful what you mentioned. So basically, Vishnu is trying to say that this plane craft which they have built is actually running on a simulated environment, which is like on NVIDIA Omniverse and Isaac to match the reality of this particular world. So as we speak, I think the plane is already flying in that simulated environment, collecting those data points, which is similar to this reality in terms of, say, in Bangalore. They would map the entire city in terms of what are the data points, what would be the physics of the weight of the entire aircraft and everything. So that is happening on the simulated world as we speak. And then once the data, everything is collected and train this plane, which is like once Vishnu and the team is completely confident, is when it will fly in the physical world, but the plane will still feel that it is flying in that digital world itself, right? So, did I explain that correct, Vishnu? Like, I'm not sure.
No, absolutely. Absolutely. Oh, yeah? Thank you for that.
Okay. So I think a lot of students are watching and I'm like, that is one question, like how do you simplify them? Like, what is happening and why are these platforms helping in terms of leapfrogging? Like you mentioned, right? Hours of labor work and time, you literally optimize that entire part by just simulating those environments, physical environments, stress and testing it out. Vishnu, can you give some numbers in terms of how this is a kind of a breakthrough compared to the traditional way of how things were going, and how much time can be saved if there is any numbers, figures, just to just for our viewers and say some investors who are watching, get some context in terms of how you're able to leapfrog, and why is this the biggest breakthrough in the tech domain right now as we speak? Yeah.
Right. So yeah, I'll actually answer that in two parts, right?
Got it.
First of all, when you're building physical hardware, right, we already use engineering tools to simulate forces on the aircraft, right? We know what are the kind of forces that will sort of act on the aircraft, and what are the boundaries within which it would work. Here, what we're trying to now do is, as opposed to you building an entire prototype system of, let's assume, your wire harness along with the sensors, as opposed to you spending months together wiring this on the aircraft and then taking it to the field to test, and then realizing that this is not going to happen, then come back, you go back to the drawing board and start sort of redoing your sensor architecture in terms of how it's placed. These have huge implications in the entire design itself, because moving hardware that you've decided where it's going to be placed on the airframe to a different location is actually going to consume not only your team's time, but it's going to affect the work stream for all other teams as well, because there are other subsystems that now have their things that need to get moved around as well. So this would easily allow you to sort of save at least a few months of effort in case you decide to change where your sensors are being placed. That's one. Second is, it also has a huge capital risk on that, Amit, right? The time and the effort that you've now wasted doing that will now have to be recalibrated to sort of starting from scratch again. So fundamentally, it's just effort that we're able to save right away. Second is, we actually have a lot of data that we've pulled out of the subscale aircrafts, right? Now that data can also now start aiding you in your entire tuning process. So otherwise, what you'll end up doing is building the aircraft, then you'll put it in the real world. We do something that's called a tethered hover, right? So you tie the aircraft down so that it doesn't flip, and then you sort of control the PIDs. There we typically take anywhere between 8 to 12 weeks to sort of arrive at a basic architecture. That will now we'll be able to shrink that to a little bit, because we now have a 70% complete model, if I may. The remaining 30% you will have to tune it on the aircraft, but 70% of the time that you would now spend doing that, you can now do it on a digital environment and then bring that slightly more mature model onto the aircraft in the test facility itself.
Amazing. So Preet, how does it feel to listen to this, and what do you have to say?
No, of course, it's very I can just sort of visualize the amount of work that's gone in, because physical engineering, or especially taking on an entire new segment of transportation, is a huge challenge. And of course, startups like ePlane have taken that problem head on and are solving it in India. That makes all of us very proud. I think my question to Vishnu would be, I think aerospace engineering isn't new. People have been designing aircrafts or helicopters, but when it comes to eVTOL, how should the mindset of engineers change while they're at the startup? Or what new constraints emerge? Or I'm not sure. Is it much easier to design and simulate an eVTOL as compared to a commercial, small scale aircraft? So I'd love to see what Vishnu
that's a
has
good
to say
question.
with that.
Yeah,
Right.
Vishnu.
Perfect, right? So eVTOLs, right? So we build what is called eVTOLs. eVTOL stands for electric vertical takeoff and landing. Helicopters are VTOLs, vertical takeoff and landing system. Essentially, what we're ending up doing is we're making this a lot more safer compared to traditional helicopters, because helicopters have a single rotor on top, right? Which means that ends up becoming the single point of failure, which means if you are losing your main rotor, then there is no recovery from that. We do what is called distributed electric propulsion, which means we take the amount of load that is required from one large rotor disc, we split them across 6 smaller rotors on the entire airframe. What this allows us to do is that it allows us to now increase the reliability of the entire platform, which means we are now certifying the aircraft for what is called an OEI, or a one engine inoperative condition. So even if one vertical rotor were to fail, right, you continue being able to vertically operate, because the other 5 would be able to take over the amount of load that was generating, which is why we've actually chose the 6 sort of rotor system, right, and not a quad, not a 4 rotor system, because here we're able to guarantee you that you can sort of even continue vertical flight itself despite having one propulsion going down. So while it might seem more complicated on the whole, what we're essentially doing is we're building in a lot more reliability, right? We have actually 7 layers of redundancy built into the entire aircraft. such that there is not a single point, the probability of a single point of failure is very, very low. There's not a single piece that would sort of cause chaos to the entire system. That's what we are able to sort of do on the reliability front.
Right, right. I think, Vishnu, now if we just keep the tech aside and in terms of logistics, right, when people have a lot of these questions when they talk about eVTOLs coming into urban mobility, like how does the entire process look like? Where will these vehicles take off? Where will they land? And where all can they land if they were operating in a metro city like Chennai or Bangalore? If you could visualize the entire process of how it would look when ePlane is reality in a city.
Excellent question, Supreet, right? So in phase one, right, the government of India or DGCA, which is the regulator here, has already put out mandates and the framework around how they will certify what is called a vertiport. Vertiports are what used to be helipads. That you think of helipads. It's for eVTOLs. It's called vertiports, right? In phase one, we would like to start partnering with existing helipads and get them converted into a vertiport, Supreet.
Right.
A city like Bangalore, right, has about 91 helipads, out of which only 3 are operational. There was actually, a building code in 2014 that came out that mandated every 18-story building have a helipad for an emergency evacuation in case there was an emergency there. Right. So it became a point of compliance, right? Which means there is a lot of buildings in Bangalore that have helipads that are there simply to just sort of check that box on the compliance front. But there's no real operation because helicopters are a lot more expensive to operate. That's fundamentally why that market didn't take off, right? Right. Now, what we want to do in wave one or phase one of deployment is start partnering with these existing helipads, Supreet. Okay. And and even today, my team, I have a team that does the mobility analysis, right? Which means we look at corridors in the city. We look at where is traffic moving at what part of the day, right? And then we look at what are the densities that we can sort of command, and that intelligence is what is driving our partnership effort on the vertiport front. So we've actually done these mobility studies for cities like Bangalore, Delhi, Chennai, and that's what's guiding our effort on the vertiport development plan itself. So there is a framework in place. We will start, sort of leveraging existing helipads to begin with, and once there is uptake, right, and the market grows, because see, this industry will grow quite exponentially because the cost of operations is not too much, Supreet, right? Right. It will not cost you more than 2.5 to 3x the cost of your Uber to operate the aircraft, which means it is something that we are developing for all of us to sort of use. So so we actually did a study in India, right? Because up until 2021, 22. The Indian market was not sized, right? A lot of the global reports that spoke about air taxis only sized a lot of the Western and the European markets. We actually did a study here in India, and it said that at the price points that we're talking about, right, there is a potential for close to 200 million trips per month in India altogether, right? That's fundamentally, sort of telling you what is the kind of, demand that would exist for an aerial solution the moment you have one to offer, right? And that will, again, the moment you have that kind of, demand, you will start seeing fresh development for vertiports in itself in the city.
Exactly. And Vishnu, like you brought Bangalore among the list of cities, and Bangalore comes with its own unique constraint that they don't want a lot of eyes at higher altitudes because of course it's a defense city. They don't even let high-rise buildings to develop, and a lot of HAL's operations and the defense operations are centered around the business parts of the city. So how is ePlane going to navigate this challenge? And because I'm not aware, like what are the conversations that you've had with the regulators or operating in a defense sensitive city like Bangalore?
Right, excellent question again. I'll answer this in terms of just building blocks for the entire ecosystem, right? Right. So DGCA very clearly put out to begin with how they'll certify the aircraft. Okay. Then they put out how they'll certify vertiports. They also put out a framework on who are the kind of pilots that will start flying this aircraft. Right. There are 2 more regulations that we are waiting on, and they've already started working on it. They're now in the process of putting that framework in place, and it will be out sometime this year is my guess. But again, they've been very proactive in terms of forming these regulations themselves. Right. The 2 that are pending are, one is around the airspace, which means they're now going to create corridors on where will these operate and how will coordination with ATCs happen. That's something that we are waiting on them on, right? And then they're in the process of putting that together. They're now studying models that are available, world over, best practices that the USA follows, FAA follows, ENAC of Brazil follows. So they're looking at how does this happen today in high density helicopter operation corridors? How does that work, right? And that is one. Second is there is also a lot of digital infrastructure that was built around drones, right? And I'm pretty sure that they will look to leverage that as well.
Right.
Like you rightly said, right? Bangalore's airspace is quite complex because it has 3 active runways if you think about it. There is BIL, there is Yelahanka, and then there is HTL.
Right.
And there's also Jakku in between,
Yep.
right? So we are actually working with them on having these corridors enabled.
Right.
Got it. Okay, okay. That was quite interesting. I think we'll bring Vishnu back on the call.
Yeah.
When that happens, Supreet, like, I mean, that was a very valid question in terms of like what should the policy,
come in Bangalore,
policymakers, think about it and all of that. But again, coming back to NVIDIA's like Omniverse and aerospace simulation, because that is where I think it's kind of a game changer for us. Say the digital twin uses like Omniverse for multi-physics modeling and system integration there. So like if Vishnu is back, I would like to know like what new engineering capabilities becomes possible when simulations mirrors reality at high fidelity, right? So that is kind of pretty interesting area there. And how does this infrastructure compare with what global aerospace leaders use today? Vishnu is back. Did you hear the question?
Got it.
Yeah.
Right. I did. I heard the question.
Perfect,
right?
perfect.
So, so Amit, these aircrafts are what's called born digital, which means they were born in a digital era, right? Which means it allows us the capability to sort of lay in those data pipelines much ahead in the design phase itself, right?
Nice.
A lot of older planes have a lot of technical debt that's built up because they were certified a lot more long back in the past, right? Which means they will need to go through a small recertification, and that fundamentally has a huge economic constraint on how those choices are made. Because we are now, this aircraft is born digital, we are now able to sort of lay out data pipelines that allow you to create digital twins that improve the predictability of failures, right? Which means predictive maintenance is going to be, something that is key for the entire operations of the entire aircraft itself, which means we will know exactly when to sort of plan maintenance for a particular aircraft because of the amount of data that we're able to collect on board and then process it subsequently. And that is what is also allowing us to sort of keep the maintenance cost low, because you're able to predict this a lot longer, which means we as an OEM are also able to predict what stocks need to be held in what parts of the city, when do you need to sort of have downtime on the entire thing. So it sort of improves the efficiency of the entire fleet operations in itself. These are some of the use cases that this entire tool is now enabling for us, Sumit.
Got it, got it. Vishnu, just a quick follow-up question on the certification and the sovereign aerospace capabilities there. Like you mentioned, digital twins enable like validation of extreme edge cases before physically testing it, right? So how can simulation accelerate certification timelines while also improving the safety assurance? And also, what does sovereign aerospace capability mean in the AI era there?
Got it. So fundamentally, right, what we are trying to do is demonstrate to the regulators that you are able to meet a certain safety standard. For aerospace, right, for whatever we call as critical path, right, to the design, we have to prove to the regulator that there is only one incident in 1 billion cycles of operation. Right? Statistically, we break that down over n number of airframes, and then we demonstrate that. Even before we get there, we now have data on these edge cases that we're able to present to them. Which means we are actually preparing them for before we actually show them the actual flight data itself. We are able to work with them from today on what are these edge cases and how are we able to handle these edge cases in the air. Right? So that is what that is how it helps us sort of improve reliability and prove that reliability exists to the regulators. That's what we're able to prove with the entire solution.
Amazing, amazing. Just a final thought. I'm sure like a lot of viewers also will be thinking like, when will we get to see this in the physical world, right? What is your estimate? And if everything goes according to plan, the policy, the regulators, and everybody is on board, and it kind of solves the urban mobility problem there. Because in Bangalore, every time I drive to work and I look at the sky and I'll be like, the sky is empty, there's no traffic there. Can we have something there? Is the question that I keep asking. And I'm sure a lot of people would be thinking the same when they're stuck in traffic, or commuting becomes so cumbersome. They take like 1 kilometer takes about 1 hour sometimes. But I think this kind of solves the urban mobility crisis. I think the new age mobility needs like new thinking. I mean, that's the only way that congestion can be solved. So how soon can we expect this, Vishnu? I think I'm sure a lot of viewers would be asking the same question. Like,
Right. So actually, the full-scale aircraft is, sort of ready. We're starting ground tests very soon, Amit,
okay,
right? And
okay,
we set out of IIT Madras, so we've now built, a facility there that we can do ground tests in.
got
This
it.
is an integrated facility, which means there's a lot of instruments there that's able to measure a lot of forces from the airframe. There is a very detailed process on how ground testing happens. So we're actually just about to, go ahead and start that.
Got
After
it.
that, we then do the tethered and then untethered flight. So, commercially, we're looking at end of 27.
Got
That
it.
is when you will commercially start seeing the aircraft, but you will start seeing the aircraft fly in a couple of months, right? We're going through ground tests right now. That's where we are at of the full-scale aircraft itself.
Got it. But right now, as we speak, it's flying in the Omniverse ecosystem there.
It is.
So it's already
It is.
flying in the environment. Amazing. So you have
Correct.
one final message. You mentioned about IIT Madras. I'm sure we have a lot of our viewers from IIT Madras who share our work, and I mean, they're the constant supporters who will be watching this. So one final message for all of the viewers that are watching, Vishnu, like where are the biggest opportunities in aerospace and autonomous systems over the next decade, according to you?
Right. I think in terms of the mobility is a huge place where autonomous systems will come in. Although aerospace as of today will not allow you to fly autonomously until you have, as long as you have a passenger on board, you need a pilot on board, right? That's the system. But where that gives you the opportunity is to be able to mine the data during these piloted flights that sort of make sure that your data pipelines for autonomy are a lot more robust, right?
Got
So
it.
that is one great opportunity. Drones are huge, right? And they have both commercial and defense implications. There is a regulation that we are awaiting called BV laws, beyond visual line of sight, right? The moment
Correct.
that comes out,
Correct.
you'll start seeing the drones uptake for logistic use cases quite a bit. And we've worked a lot with the regulators here to sort of show that so we've built a lot of drones building up to the aircraft. So a lot of that work is sort of getting leveraged. So that market is huge as well, right? In terms of being able to create these cyber physical systems, because AI will not exist on its own, right?
Correct.
You need you need a physical implication of that, right? And that is where the opportunity lies, because if you're doing everything on the virtual world, the change there, right, or the time to untrue in that world is very, very quick, right? But in the physical world, it's a lot more different. So cyber physical systems are where the next large opportunity is, right?
Amazing.
And mobility is going to be one of the biggest verticals where its impact will be felt quite strongly.
Amazing, amazing. I'm just before we wrap up, Vishnu, I just did a bit of research, and I got to know that in your early years you built accessibility technology for visually impaired children, and then today you're working on making air mobility accessible at scale, which is pretty interesting and inspiring. I think a lot of viewers who are watching this would take a note on this. Has your definition of mobility evolved over the years? And what does equitable mobility look like to you in the future, Vishnu? Just on a final note.
Right. So the ePlane company is the name of the company, but the registered company is called UBFly. It is ubiquitous flying. It's called UBFly technology, right? The founder, Prof. Satya Chakravarti, the reason I decided to join his mission is because he said he wants to build a 100-year-old company, right? And he said that he wants to democratize flying, and that's fundamentally what got me to join this entire mission, right?
Wow.
Access is fundamentally what we're trying to break, because this is not something that we're building for just a particular class of society. We're actually building this for everybody. As a matter of fact, the first variant that we're certifying is an air ambulance, right?
Wow.
The cost of accessing that air ambulance will be comparable to ground transport. Every time I am in Bangalore or Chennai and I hear an ambulance, my heart sinks. I don't want anybody I know, or God forbid, I don't want to be in that situation myself, right? So equitable accessibility fundamentally means ensuring that you are able to now get everybody move forward with you as you build tech. And that's what's sort of always driven me, and that's what I did right out of college. And that's the reason I sort of continue contributing to this mission as well, because access to mobility should be sort of equitable in that sense. Everybody should have access to an air ambulance if required, right? That's what we're building towards.
Amazing. I think you summed up very beautifully. Thank you for that, Vishnu, and thank you for your time. And I wish you and your team all the best and all the success in whatever endeavors you're building. And I hope I get to experience this once you launch. And I'm sure we'll be bouncing back in terms of all the new updates that you guys are releasing. And we're keeping a close watch on ePlane company there in terms of what you guys are doing, innovation and all of that. While we do that, we would love to have you back on the show time and again in terms of any new development and any support from our ecosystem as well in case you guys are hiring. Is there any new role that is emerging, and what are the kind of talent that you're looking for? Happy to spread this message through our platform. I'm sure like eagerly a lot of people are looking into this, and this is a great opportunity, untapped, unexplored, and there is a problem, there is a solution, and nice to see that it's happening in India. Thank you so much, Vishnu, once again. Any final message to the viewers before I let you go? Yeah.
No, thank you so much. Can't wait to show you guys what we're building. Right, we'll probably invite all of you over very soon. Right, and we get to sit in front of the aircraft and then continue having this conversation. And not in the virtual world, but the real world with the aircraft. There.
Yeah, definitely would love to do that. I think Supreet has been very active in this particular domain as well. That's why he's on the show today. He's been interacting with a lot of these founders who are building this, both on the commercial and all of that. Yeah, I mean, excited to see that in person and meet you in person as well. Yeah, thank you, Vishnu, once again for your time.
Thank you, Vishnu, and all
thank you,
the best.
Thank you for that. Thank you for having me.
Thank you.
See you guys.
Yeah, Supreet, what do you have to say? What is your concluding remark, or what did you enjoy from this conversation? Like,
I think it's a bold vision, and I just can't wait to be a part of a city that lets me fly in the air to get to my destination. I think that's pretty much what I have
That
to
is
say.
pretty much what it is. And I think, Supreet, there I think a lot of companies also working. You met
Sarala
Aviation as well. So there are so many companies coming. The opportunities, like it's plenty there.
Right.
So yeah, I think. I'm like loss of words in terms of how this conversation happened.
Right.
But again, once again, thank you everyone for watching. This is your AI talk show by AM Network. Think AI.
Think AIM.
Yeah, thank you.